Hello, we try to solve another questions for truss analysis topic. So this diagram is showing there's a roller supporter and fixed supporter, and you have the members of A, D, C, B, and D, B. So determine the support reaction forces at point A and point B, and the force in each member of the truss. So you have the member DC, we need to find the force, and the force in member CB and DB, AB, and DA. Also, we want to state if the members are in tension or compression. So step one, to solve this kind of questions, we need to find the free body diagram. So step one, free body diagram. I just took this drawing on the side and converted whatever forces I have. So the first, I'll replace this by one support reactions called AY, and at point B I will replace it by two support reactions which calls BY and BX, and soon I will explain how it's working. If you pay attention to this question, you see that there are external forces on this diagram. The only external forces at the moment with the support reaction is the 400 newtons. When we have the support reactions, we need to determine forces, concurrent forces, or forces using non-concurrent. So that's why we need to introduce the moment. So if we start in step 2, find the support reaction forces. Algebraic summation of forces in the x direction. If you look carefully in the diagram, there are no forces, external forces on the x direction except the support reaction Bx. And that means that Bx is not working, is not active at this stage, because the location of the 400 newtons is it's on top of the Ay. Therefore, Bx is equal to 0. When there are no forces, Bx is equal to 0. Now, if we take the moment around point A, you find that force Ay will be cancelled, equal to 0, because no distance. Force 400 Newton passed through the point, and the Bx is also passed through the point, plus we know it's equal to 0. So the only force we have a By, which is the distance 2 meters, as stated here. So B2 By times 2 is equal to 0, By is equal to 0, and that again explains when you have 400 newtons, so all the load of 400 newtons is supported by the roller exactly here, because it's on top of it, perpendicular on it. Now, if we try to find the summation of forces for the support reaction at Ay, so algebraic of summation forces in Y, so I assume everything is going upwards is positive. This is kind of something we need to do all the time, so the reader understand my positive X direction is that way, my positive Y direction is that way. So therefore you have Ay minus 400 going downwards plus By, but we know in advance By is equal to 0. So Ay plus 0, the By is equal, you transfer the 400 to this side, so it will be Ay is equal 400 newtons. I solved this question in advance to save you from time, because it would take longer than 15 minutes, but you can try it and follow the steps. Now, step 3. So to revise, step 1, free body diagram. Step 2, find the support reactions. We locate them, we put them in the free body diagram. So now I take this copy again, make sure I bring my positive X and Y to know the direction. Step 3, pin at C. So I take this pin at C. We'll apply the concurrent forces topic where we learned. So algebraic summation of forces in Y direction and X direction, and then we determine the values of the members. So first we'll start. What you have at point C, you have a 400 newtons, and you have the member force FCD, and you have the member of force FCB. CB is inclined with 445 degrees, because you have 2 meters and 2 meters, so this one will be 45 degrees, and this will be 90 degrees to give you 180 degrees total angles of the triangular. Therefore, we start now to find the components for FCB cosine 45. Remember, when we're moving towards the angle, it's cosine. When we're moving far away from the angle, it's FCB sine 45. So summation of forces in Y direction is equal to 0. So what do you have? You have 400 newtons and is positive plus the FCB sine 45. If you look carefully, it looks like I assume the direction is wrong, because you cannot have both forces going in that direction. It means there is no support reaction. Therefore, the correct direction should be going upwards, and that's where I should state here when I got the negative answer. So this FCB is actually is compressive, so I can just write in bracket C to represent, I'm explaining it as a compressive. So C represent compressive, T represent tension. So since it should go on that direction, I assume it as a tension force, but actually the answer is giving me negative, so it should be as a compressive force. Now, summation of forces in the x direction, what do you have? You have FCB cosine 45 degrees positive, based on my assumption, minus FCD, which is in that direction, and then you solve it, you will get the answer for that force. Because I took this value, so therefore I'm also getting FCD to be negative, so that's also this force it should be, if I assume it's a tension, no, it should say it's compression. So that's why I need to always state these things to make sure what we're doing, it's making sense for the readers. Right, now we finish pin C. So in pin C we determine FCD and FCB, so these two members. Now we go to step 4, pin A. So pin A, what do you have? You have the 400 newtons support reaction, you have the FAB in that direction, and you have the FDA in that direction. Therefore, I will apply the analysis. Again, this is equal to 2 meters, and this distance is 2 meters. You can see them from those directions. So the angle is 45 here and 45 there. So FAD cosine 45 degrees, FAD sine 45 degrees for FAD. So algebraic summation of forces in the y direction, again this is going up, is positive. So FAD sine 45 and plus 400, again because I assume it wrong, so it's giving me FAD a negative, and that means this force also is, so if I am assuming it as a tension, like going away from the point, so the right answer should be compression going towards the point. Now the same thing if I apply algebraic summation of forces in the x direction, I have the FAD, but should be negative, plus FAB is equal to 0. Taking the value here, so FAB will be minus 400. So if you look to FAB, it's supposed to go in that direction. So it's applying for me as a compressive support to my solution. So this is to find the members forces for AB and AD. Now, so we did first pin C, we did pin A, now we go either pin B or D. So I'll start with step 5, pin D. What do you have at pin D? You have an angle we need to determine, which is this one. So how we determine? I just extended this line here, intersect with this point. So this distance is 2 meters plus 2, and the top one is equal to 2. So very easy to find this angle. If you forget, I'll write it down for you here, guys. So that's, if we call it theta for this angle, let's find theta equals to tan inverse. So let's write that. So tan, if you want to learn how to do this in the future. So what do you have? In tan inverse you have two values, so 2 divided by 4, and you make sure to convert your calculators in degrees to 26.6 and the answer in degrees. So that's how we determine the angle. Alright, now the other angle here, as we say earlier, this one is represent 45 degrees for the member FDA, because 2 meters 2 meters. So I have seen here, or I have shown you guys how to do, or in the class before, the components for FDB and FDA is just cosine. If I'm moving towards the angle, will be cosine the angle. If I'm moving far away from it, will be sine the angle. So one is for sine 26.6, the other one sine 45. Algebraic summation of forces in the x direction. I only needed the x direction because I have the values for the point FTA. The only thing is missing for me is the member in the middle, which is FDB. So FDC, it's known, which we found it previously. and FDB cosine 26.6 degrees is the one we're trying to find. So FDC is 400, FDA is cosine 45 degrees, and you substitute the values, rearrange the equation, you find FD, and that's represent is the only one I have assumed it's correctly at the beginning, which is tension, because it's the direction of it. Since I got a positive number and it's going in that way, going away from the point, so it's applying a tension, starting to pulling the member of that point. These kind of questions could change from different scenarios, but I'm showing you here like some support reaction in this example. They are equal to 0, because if you see the location, it's 400. But if we switch or move the 400 newtons from this point C or pin C to pin D, definitely the answer will be completely different. Even if we put that force in different direction, inclined with an angle or going in that direction, could also again will change the equation. So what I will suggest to you guys, since we've done this, if I go back to this question again, if you can try at home and try to solve this question by switching this angle and make it easy for you in that direction. So let me show you. Just do it here. So instead of solving in that way, I want you guys to try at home to resolve this question and putting this external force at that point. And you need to repeat the same 5 steps what we did, and definitely you will get different support reaction forces, different values for everything, because now the load is at that point. So I predict that the support reactions AB need to support more, and that's what we need to find. So please try to solve this with switching the 400 newtons at that end. Alright, so I hope you enjoy this class, and I hope to see you very soon. Take care. See ya.